Congratulations on hitting the end of this chapter. This chapter was all about constructors and initialization. And we have seen many ways we can control how our objects are built through constructors. We started out by looking at default parameters, and we saw that it is possible to specify default arguments that are going to be passed to our member variables as our objects are built. And when we do this, users of our class are going to have an easier way to construct our objects without specifying what is going to be put in our member variables. We saw how easy this could be. We then moved on and looked at initializer lists, and this provided a new way we could use to pass our arguments to our member variables. And this is in contrast to what we did before, which was basically member-wise assignment in the constructor body. We then moved on and looked at a simple comparison between member-wise copy initialization and initializer list initialization. We basically saw that member-wise copy was doing things in 2 steps, and that we could avoid these 2 steps using initializer lists. You should also know that some things are really only possible through initializer lists, and we're going to see a few examples of that as we progress in the course. We had a chance to look at explicit constructors, and we saw that this was a way to prevent your own constructors to be used in implicit conversions. Next, we looked at constructor delegation, and we saw that this was a way to reuse other constructors from our own constructors. For example, here we have a simple constructor that is using the other constructor which takes 3 parameters. So now that constructor delegation is set up, we don't really have to do the hard work in our own constructor body. We're going to let the other one do the heavy lifting, and when it's done, control is going to come back in our own constructor here, and we can do whatever it is we want. We saw that this could make things really easy, as you don't have to duplicate code in all the constructors in your class. We then looked at copy constructors, and we saw that these are constructors that are used to copy your objects. We saw the syntax to do that. You have to pass your parameter by const reference, as you see here. And inside we could do member-wise copy if our member variables didn't have any pointers in. If we have a pointer, you have to remember to do deep copy. So you are going to set up a new memory location and then copy the data in. You don't want to copy the pointer as is, as we have seen that could really have really bad consequences for your objects when they get copied. We also saw that it is possible to do copy constructor delegation, and by setting up things like this, we delegate the job to construct our object to other constructors. For example, here our copy constructor is delegating the work to another constructor which happens to take 3 parameters. And this other constructor is going to do the job to set up a new memory location for our pointer member variable, and everything is going to work fine. You notice that we are dereferencing from the source object here and just giving the data, which is going to be stored in the new memory location. After that, we took some time and really tried to understand the difference between shallow copy and deep copy. We saw that shallow copy was doing member-wise copies. So if we are trying to construct an object P2 from P1, what we are basically doing is member-wise copy. So we take the last name and paste that into P2. We take the first name and copy that in P2, and then we take the age, which is a pointer, and copy that in P2. And this is going to copy the pointer address. And after our copy, these 2 pointers will be pointing to the same address. So if we modify something from P1, P2 is going to see the changes, and this is really not what we want. We saw that we could avoid these problems with pointers by doing deep copy. And a deep copy is going to set up a new memory location. Once that memory location is set up, we're then going to copy the data and store that in. And after that, these 2 objects will be pointing to 2 different memory locations. And if you change something from P1, the change is not going to be seen in P2 because P2 is basically pointing to a different location. And this is what we call deep copying. We then looked at how we could use move constructors to steal data from other objects. And the trick is really to steal the pointers and make them our member variables, which is what we are doing here. And after that, we have to invalidate the source object and make it point to null pointer so that when it gets deleted, it doesn't delete the data that belong to us now. And we have seen how we can do that. So if you want your move constructor called, please remember to pass your source temporary object through stdmove to be able to see that. Because we have seen that compilers sometimes do optimization to hide this from you. We had a chance to look at deleted constructors, and we saw that this was a way to disable some constructors from your class. For example, here we have disabled the default non-param constructor, which doesn't take any parameter. We have disabled the copy constructor. This is a copy constructor because it's taking the parameter by const reference here. And we have disabled the move constructor, which is used in this syntax here. Once we have this disabled, if somebody tries to set up a piece of code which is going to call these constructors, we're going to get a compiler error, and we had a chance to see an example of this. We then looked at how we could set up initializer-less constructors for our own types, and this is the syntax. If you happen to need this, you're going to go through the syntax, and your data is basically going to be passed through an std initializer-less object. And then we're going to go through this and grab the data. We saw that it was possible to loop through this list, but here in the body, we are just using pointer arithmetic to grab the first and the second element, and then we assign those to our member variables, which are x and y here, and the data is going to end up in our member variables. We then had a chance to look at a few other things like aggregate initialization. We showed that this was a unified way to initialize aggregate types. We already know aggregates are something really complex and confusing in the C++ documentation, but we tried and gave you a simple definition. So far, we really know about two aggregate types in C++, and that's array and struct. And we saw how we could initialize these things. After that, we looked at designated initializers, and we saw that this was a new syntax introduced in C++20, which allows us to be very specific about which member variable we want to initialize in our aggregate type. After that, we looked at uniform initialization. We saw that this was an effort to try and make it really straightforward to initialize our objects, and we saw that it was possible to use parens or curly braces, and we saw a few differences between these two things. We saw that curly braces didn't allow narrowing conversions and parens allowed narrowing conversions, and you're going to have to choose whatever makes sense for the problem you are trying to solve with C++. This is really all I had to share in this chapter. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about friend functions and friend classes. Go ahead and finish up here and meet me there.